Alright, now that we've taken a quick look at the player class, in this video we're going to code that class, and by the end the objective is to have, well, I guess 2 players running around on the screen, one that I can control and one that Logan can control.
We would have 4 players, but we ran out of Xbox controllers.
Exactly. Alright, so with that, let's go ahead and get started.
Alright, we need to begin with the player class. So we're going to go down to Game, and we will add our new item for player. A little bit of setup needs to be taken care of. We'll add in some using statements. So we'll be putting in usings for framework and framework.input. So Microsoft XNA framework, and we're also going to need a line for framework.input for all the input handling we'll be doing. I'll also take off the .game sub namespace, and now we're ready to begin our work on player.
Okay.
The first thing we need to put in is some fields. First, the static array of players. So this will be a public static player array, which we will call players. And we also need to hold a, actually I think that's the only static member that's going to be part of this. Oh no, not static member, static field. We'll have some static methods here shortly. So let me jump down a line and we'll group all these together. We're going to have, for each instance of player, we'll have a ship that player owns, and we will also maintain a last key state and last gamepad state for each individual player. We're maintaining key state and pad state so that we can detect when a key or button is first pressed and then first released, to be able to detect that as one press. That allows us to do things like single projectile weapon spawns, where instead of having the projectile spawn continuously as long as the button's down, we can instead detect that one press was pressed, and I have to actually have a release and then a subsequent press to refire. But beginning with the player ship, this is going to be a public field. It is of type player ship, and we will simply call this ship. Alright, the other 2 fields are the input states. First is a keyboard state, and we will call this last keyboard state. These are both going to be private to the player class. And the second field is the gamepad state, and that's some good spelling. And that will be called last pad state. Alright, with those fields out of the way, we can address all of the static methods of the player class. This includes the static constructor, which initializes the player's array, and then we'll have methods that allow spawning ships, removing ships, and processing input. So let's begin with the static constructor. This will be static player, and inside of here we're going to initialize the player's array and then make sure that each element of that array points to an actual player instance. So looking at the player's array, that will be a new array of player with 4 elements. Then we'll turn around and we'll loop through all of those elements. So looping through I is 0 up until players dot length. Then we'll take each player, so players sub I will be equal to a new instance of player. So this is where, right off the bat, we get 4 actual player instances in place ready to handle input, so that if any of these players plug in a gamepad and press start, we'll have the necessary player classes in place to hold them. It should also be noted that the player instances will never themselves get removed. It's the player ships that can be destroyed, not the players. This is how we have specific players maintaining gamepad inputs without rearranging themselves every time maybe a player joins or a player leaves or a ship spawns or a ship dies. I'm also going to take this method and drop the additional brackets off of the for loop. Alright, moving on from here, let's skeleton in the remaining methods just to make sure that we don't run into any interdependency issues. So let's get spawn ship and remove ship. Both of those are public static methods. Spawn ship is going to need to take in, actually it's going to need a return type. It's going to take in a player index. Basically we'll be able to ask the player class to spawn an actual ship for any one of the 4 players. and we'll address those players by player index. Next we have remove ship, and this will once again be a public static method, void in return type, and this will be called remove ship. Remove ship is going to take in an actual reference to a player ship. We'll just call that ship. And remove ship's job is a way that something externally can alert the player class as to the fact that a ship has been removed. This will be called from within the actual player ship class, since it's from within player ship when we know that we have been removed. This is where we need to go in and set the specific reference to a ship back to null, so we know that we're no longer controlling a ship.
That's right.
Moving on from here, we have a static process input method. So we'll drop in public static void process input. And process input takes in no parameters. Its job is going to be to loop through all players and then call the instance process input for each individual player. So to skeleton that in as well, we'll have void process input, and this process input is going to take in a player index. Because this is the one where we'll manage the state individually per instance, so we need to know exactly which player is it that we should be looking at for input.
Okay.
So these are all of the methods that we'll be needing. Let's go back up to spawn ship and begin implementing them. Spawn ship needs to look at the current array index for the given player index and see whether or not the ship is currently null, because we're only going to allow the spawning of a new ship if we're missing a ship. We don't want to allow the player to continuously spawn more and more ships if that slot is already filled.
That's right.
So we'll do a check and we'll see that if players... Now here's something interesting. We're about to try to look into an element. Basically we can have a player index of 1 through 4. And we have the players array with elements 0 through 3. We need some way of referencing the array elements by using the player index. Now of course player index is an enumeration. We can look at what values are associated with it. If we jump into it and say go to definition, we can see that these textual names 1 through 4 are actually represented by the numerical values 0, 1, 2, and 3, which convert nicely to array indices. And to convert them, we can simply cast them over. So to access the desired element in the array, we'll do the int casted result of the given player index. And that should resolve an element within the array. Then we can look at that element's ship and see if it's equal to null. Because if it's equal to null, then we're missing a ship for that slot and we're allowed to spawn one. So then we'll take players sub whatever player index we've got, so int cast result of player index, and we'll say that its ship is equal to a new player ship. Now we need a sprite sheet in order to instantiate the player ship game item. For the time being, I'm going to leave this be player 1 or ship 1. We'll get into using different graphics for the different players here in an upcoming video. So I'm going to use the existing sprite sheet held in config called ship sprite sheet. So for the moment, every player joining will get a red ship, but we will have independent control on those ships. And that really takes care of spawn ship. Really just a matter of, well, literally doing just that, creating a new instance of player ship and then storing it in the appropriate slot in the players array. Moving on now, we can address remove ship. This one is a little bit more interesting because now we have to do a lookup and actually look through the array, searching through it element through element until we find or don't find the given ship. And the reason that we're going to do this lookup instead of simply taking in an index to remove ship is because a player ship does not know what its index is. Whereas on the other side of it, we can look through the player's array and compare the ships one by one to see if they match the given ship. Now to accomplish that one by one check, we're actually going to use a loop to go through all players. So we'll begin a for loop, and we'll be looping from 0 to players.length. And what we're looking for is to see if the given player is, actually if the given player's ship is equal to this provided ship. So if players sub I dot ship is equal to the specified ship for removal, that is ship. Then we know we found that ship and we want to remove it. So we'll take players sub I dot ship and set it to null to indicate that there is no more ship at that location. And I'm also going to pull the curly braces off of the for loop, as we have only one single if statement inside of it. And that really takes care of remove ship. Now we can move down into process input. Process input's job is simply to loop through all players and and call the process input instance method, or excuse me, process input method for each instance of player.
That's right.
So this will be a for loop that once again goes through all players. So we'll go through players.length, and then we'll take each player, players sub I, and we'll tell them to process input, but we'll be giving it a player index. So we'll give the player index casted results of I. So here we're actually converting in the other direction from before. We're actually taking I and we need to derive a player index from it. But again, since the numerical value is tied back and forth directly, we can just cast I directly over to a player index. So terminator for that line, and that takes care of the for loop. And that takes care of all the static methods. Now we need to address input handling on a player-by-player basis. So this is where we get into the process input method. The first thing that we'll do inside of here is get the current keyboard state and the current gamepad state for the given player. So we'll make a keyboard state local variable called keystate, and that will be equal to keyboard.getState for the current player index. And on the keyboard, I'm dropping in player index just in case you would for some reason want to grab the individual keyboards off of, for example, a controller-based chat pad. This has no real bearing on the PC-based keyboard input at this time. We're also going to grab the input for the current gamepad. So we'll drop in a gamepad state, and we'll call this pad state, and that will be equal to the current gamepad. And we'll use the current gamepad, and we'll tell it to get state once again for the given player index. Now that we have current up-to-date game state information, or excuse me, input state information, we'll now do a check and see whether or not this instance of player is associated with an actual player ship. If it has no player ship, then we'll be looking out for the enter button on the keyboard or the start button on a controller to potentially spawn a ship. If we do have a ship, then we'll be looking for either directional keys or joystick input, and at a later time, fire button input. So the check here is now if this dot ship is equal to null, then we need to handle the possibility of spawning a ship. Otherwise, we need to specify input for an existing ship. Now, if we're looking for a ship, we'll first check the keyboard and see if the enter button is pressed, and if not, then we'll check the gamepad and see if the start button is pressed. So if keystate.is key down, and we'll be looking at keys.enter. And we'll make sure that this is just one press of the key. We don't want to run into a scenario where we could just read the keys continuously being down. Even though this should pick up and the ship should immediately stop being null after we spawn ship, this is really just provided more as a precaution. We're only looking for one key press. So if the key has just been pressed down and the last keyboard state key is up for keys.enter, then we know that the enter key was just pressed. And if that's the case, then we'll take our player, we'll say player, as a matter of fact, since we're in player, we could just say spawn ship player index dot, actually player index dot 1. What we're going to do with the keyboard input is lock it only to player 1. Now we'll do the same check, but this time for the gamepad button press. So that's if pad state dot is button down. I'll be looking at buttons dot start, and if on the last tick the button was still up, so if last pad state dot is button up for buttons dot start. If that's the case, then we once again need to spawn a ship, but this time we can spawn a ship based on the given player index, because in this case this could be any of the 4 controllers that are spawning. So we'll use whatever controller we're getting input from is the ship that ends up getting spawned. Now we can move into the input for controlling existing ships, because if we ran into a scenario where a ship was not null, we jumped onto the else block, and we need to start getting things like player movement information. As a matter of fact, we'll begin by actually zeroing out the direction ahead of time. And the reason we're doing this is just to make sure that we don't continuously add on to it. The way that the keyboard input is going to work is each key will be checked, each directional key for 4 directions will be checked individually, and that key adds direction in that, or towards that direction. So it would mean every tick we would continuously try to add on to direction. That's why we zero it out ahead of time. So we'll take the current ship, so this dot ship dot direction will be set to a vector2 of 0. Now we get into a slightly interesting block of code where it would make sense that we just get keyboard input, then get gamepad input and call it a day. I'm going to put a if block to restrict the keyboard input to only hit the first player. The reason I'm going to do this is because the player input the keyboard state will resolve for each one of these, meaning that even if we specify the player index of 1 through 4, key state will always get set to your PC's keyboard, and the end effect of that is the keyboard will control all existing players unless we restrict it. So I'm going to start just such an if statement to restrict it. We'll say that if player index is equal to player index of 1, then we'll allow keyboard input. And if we're allowing keyboard input, we'll check the arrow keys and adjust the direction appropriately. So we'll say if key state dot is key down for keys dot up, then we will move the direction to point into the up direction. So we'll say ship dot direction minus equals 1.
Let's go ahead and get that dot y in there.
And direction dot y. Yeah. And let's close off one of the parentheses. Now I'm going to copy these 2 lines and paste them in 3 more times so we can get all 4 directions. That's keys up, keys dot down, keys dot left, and keys dot right. So the down key will increment the y direction, the left key will decrement the x direction, and the right key will increment the x direction. And you'll notice that was, again, one of the reasons I'm zeroing out the direction beforehand, is since we're simply incrementing on each direction. The reason this is done is so that no key takes precedence over any other key, but we do maintain control where if we hit the left and the right key, then we decrement in x and then increment in x, arriving back at 0. So we can actually zero out our position by pressing opposite directions, which makes sense. If you tell the game to move in 2 directions at the same time, what should happen? But now that we have handled keyboard input, we need to grab joystick input from the gamepad. So here we'll say ship dot direction plus equals pad state dot thumbsticks dot left times a vector. As a matter of fact, that alone would work for input. The problem is the input would be reversed, meaning moving the joystick up would cause the ship to move down on the screen. So I'm going to multiply it by a vector to reverse the y direction. So I'll multiply by a new vector2 where the x component is 1 to give no change in x and -1 to reverse the y direction. Now, once we've gathered this input, we have not yet guaranteed that direction is a unit vector. we have looked at, let's see, and I could put in a reference to this.
Just to keep it consistent with everything else we've done.
With the standard.
Sorry guys, I was just passing Logan a note.
But once we've gathered input, we could run into a scenario where we're pressing, say, the up key and the left key at the same time. Then we would have an overall vector length of greater than 1, so technically we'd be able to move faster than we're supposed to. So what I want to do is normalize the direction vector.
Gotcha.
Now I only want to normalize it if it's not 0, because if we try to normalize a vector of 0, 0, then we'll end up with something that's not really a number. So we'll check first and make sure that this ship's direction is greater than 0, because we are technically using this direction vector is a little bit different than a unit vector. We're allowing a value of 0 to indicate that there is no direction.
Right.
So if if our length is greater than 0, so direction.length greater than 0, then we need to take our ship's direction and normalize it. And with that, that takes care of, let's see, really that takes care of all of the input for the case that we had a ship. If we jump outside of that, meaning outside of regardless of whether or not we had a ship or didn't, we need to update our last key state and last pad state so that those are ready for checks against the current next time around. So we'll take last keyboard state and we'll set that equal to the current key state, and we'll take last pad state and set that equal to the current pad state. So we'll synchronize those, and really I think that takes care of the player class. If we were to build now, everything builds, and so actually there's one more thing we need to do, and then we're ready to start testing this out. The one thing that remains is we need to make sure that we update our players if an actual player ship is ever destroyed. We need to make sure we mark that slot as null again. And we'll do that by going into player ship, and whenever a player ship is removed, we'll remove it or call upon player, the player class, and we'll tell it to remove a ship, and that is this instance of ship that was just removed. So now we can build, there are no errors, and now let's turn our attention back to the game class, and let's set up the necessary calls for nodes and timers to be updated, and then we'll take a look at spawning a player ship in that we can control. So we'll jump over to the game class, and we'll begin with the update method. As a matter of fact, before we even move into all of this, I think I'm going to remove all of the test sprite code that we had originally placed. So we'll wipe out the test sprite field. We'll take out our test sprite being created in begin run, and we'll take out the code to update the test sprite, and we'll take out the code to draw the test sprite. Now back in update, we can start handling process input. Right after the timer update is called is when we'll handle player input. So I'll add in player dot process input. And we also need to handle our node updating, and node updating is actually going to occur before the timer update. So we'll tell our nodes, our node.update nodes feed in the current game time so that all nodes can be appropriately updated, and that takes care of updating nodes, calling the timer. After all of this is run, we have the potential that in update nodes, some nodes could have been marked as dead and would therefore need removal. So after all of our updates, our timers, and our players are processed, then we'll look back into node and tell it to remove any dead nodes. I'll also point out that the order in which these three calls are made is actually important later when we get into pattern-based and timing-based weapons. And the reason being is that if you follow the execution of each of these through, then followed by the subsequent draw, we want to make sure that after something is spawned, meaning in cases like, for example, process input could potentially spawn a ship now. you could hit the button and see the ship appear. But if you immediately start moving, you'd want to show it in its original location before, you want to draw it in its original location before you handle update to move it even more. But again, that would be extremely hard to see with ship. It'll become more apparent with weapon if these calls are out of order. You'll have a scenario where maybe the first projectile in a series will spawn closer to the other two. And that's because on the first input he was getting spawned and moved at the same time instead of spawned, then drawn, then updated. But now that we have the update calls in place, we can go down to draw and make sure that all of our nodes get drawn. And I'll do that with a simple for each loop. So we can say for each node called node in node.nodes to grab the main list. We can take each node and draw it using the game's sprite batch. And once we have this in place, we should be ready to play. If we build, everything builds. If we run, we see no ships on screen. That's because nothing has yet told there to be a ship to be spawned. Now we should have 4 players in effect, one of which looking at the keyboard, so if I was to press the enter key, I do in fact get a ship that I can move around using the arrow keys.
Very nice. And if I was to take the controller and hit the start button...
You're player 1.
Oh, that's right.
I'm player 2.
Bummer.
But I wanted to show that first, that yes, this is player 1. And no ship spawn on startup. If I want player 2...
That does mean that I have control.
But if I want to spawn a second ship in, then I can do just that. And we see we have 2 ships on screen now, even though their textures are the same. But again, we'll get into setting unique textures for each one later. One thing that we can test now is we can make sure that the player ship's screen edge detection code is working, making sure that if we run along the edges of the screen, we are blocked on screen and we don't fall off screen. So all of that seems to be working just fine.
Yeah, how quickly I forget that I am player 1 over here looking at my controller and seeing the one slot lit up. And you have the keyboard in front of you, and we have locked the keyboard to player 1 since...
So I can sit here and fight you for control.
Yeah, since in all actuality the keyboard is picked up by all of our players.
Exactly.
So locked it
As a matter of fact, we can go ahead and show that real quick. If we go back to player, and then go back down to process input, if we temporarily comment out our if statement so that keyboard input is allowed for whatever was in player index, let's see what happens. Now if we spawn the first player, if we spawn the second player, so we're looking at moving one player around individually by using a controller, moving the other player individually with a controller, but if we grab the keyboard, both run at the same time. So the player is in fact grabbing input from anyone he can. He's kind of disregarding the player index and grabbing anyone. So that's why we put this into place, so that we can have a keyboard player playing against a gamepad player.
Very cool.
And let's see, with that, there's only one last thing I want to do, and that is to have the first player spawned in automatically when the game begins. So we'll do that from within game 1. We'll go down to begin run. We'll call upon player, and we'll tell it to spawn in a ship. The ship we would like spawned in is player index .1 for the first player. And now when we run the game, we have a ship already in existence when we first spawn in.
Very nice.
So with that has the player class in place. We have all of the necessary functionality to maintain 4 slots for players, which can maintain input and references to actual player ship instances within the game.
Very nice. And with that is going to wrap up this video. Thanks a lot.